Welcome to the National Business Review. From our studio in San Francisco, gateway to the Pacific Rim, and from locations throughout the United States, join us as we focus on innovative companies who are taking advantage of new technologies and bringing them to the global economy. With Doug Novak and Christina Mare in the studio, and Holly Paine reporting from the field, this is the National Business Review.
Our story today deals with a technological advancement that is rather unique, since most of the advancements being made today are in circuitry and computers, software, or in biotechnology. Our report is on an advancement in the field of mechanical technology.
It's an invention that stores high amounts of electrical energy, but it doesn't rely on the use of chemicals as batteries do. One day in the not-too-distant future, we may see the landscape which surrounds our cities cleared of high power lines. This technology may even help power our automobiles and offer advancements for many applications yet to be discovered. This will all be made possible because of a mechanical breakthrough.
The concept behind this mechanical idea has been around since the end of the 19th century. Yet, not until recent advancements in composite materials and other advancements in precision manufacturing of component parts has the vision of mechanically storing electrical energy taken hold. To find out more, our field reporter Holly Paine has the rest of our story.
Imagine a device that spins at tremendous speed inside a vacuum chamber and has the ability to store electrical energy and deliver hundreds of kilowatts in an instant. What is it? A flywheel, a mechanical invention that holds great promise for applications in many different industries. I'm here with John Eastwood, president of Trinity Flywheel Power here at the Trinity Engineering Center in Livermore, California. John, can you explain to me exactly what a flywheel is and how it generates electricity?
Yes, Holly, I can. It's incredibly simple. A flywheel's been around for the last 200 or 300 years, and in this case, the way that we put power into the flywheel and take it out is electrical. So you're familiar with a conventional magnet, north and south, and in between you've got lines of force. If you pass a wire through the field, you will get a current in that wire. If you put the wire in the field and then you put a current through it, it will move. So that's a very simple either generator in the first case or a motor in the second. Now, imagine you have a large toilet roll, except bigger, made of carbon fiber, and in the center of this toilet roll, in the center of the hole, there is a series of magnets, and on this little picture you'll see it here, Holly. A ring of magnets in the center, and they are made up of what look like pieces of pie. The result of this, which was invented by Klaus Hollbach from Lawrence Berkeley Lab, is that you get a linear magnetic field in the center, just like between the magnets here. If you put a coil in the center of this toilet roll, spin the toilet roll, you'll get a current in this coil. Or if you operate in the other direction, it will generate power. So therefore, you've got here a very simple motor or generator which enables you to take power in or out of the flywheel.
How many times can this process of storing up electricity and then releasing it be repeated? And is there an advantage to using this technology versus using a battery?
It's an enormous advantage. Lead-acid batteries like you've got in your car have the ability to accept 500 approximately deep discharges. In other words, if you discharge the battery completely, you can do that about 500 times, then it's a write-off. With a flywheel, you can do that 100,000 times. Wow. Or more.
And who is using this technology?
Well, initially we hoped that this would be used in the vehicular industry, and it will be. But in the first instance, in order to get sales, we're selling it into industrial applications like a hospital. For instance, you want to keep the hospital running all the time, you don't want to die on the operating table because of lack of power. So if there's a glitch on your power supply, the flywheel will take over, supply the whole hospital with power. 3 or 4 seconds later, when the power comes back on from the power utility, the lights come back on and the flywheel can go off. So that's a typical example of an industrial application that this technology makes available.
What does the future hold for this technology?
Well, I think the future is limited only by our imagination. It's a little bit like the laser. This offers when the laser was first invented, people didn't know what to do with it. And in the case here, what you're going to use it for depends upon people's imagination, because it's the first time that we've had available the ability to deliver very large amounts of power for short periods of time from a very small and compact piece of equipment.
Well, it's fascinating. No question about it, this technology already is helping to keep our factories running continuously through power outages, as John said, and yet it holds the potential of changing everything related to electric power and transportation.
It is amazing how one day this technology could be found in every home.
In the early 1960s, when lasers were first invented, people didn't know what to do with them. The applications were not yet realized. Today, anyone who owns a CD player or a computer actually has a laser in their house.
Now that lasers are almost everywhere in every home, the same could one day be true for flywheels.
To continue our coverage on flywheels, we've returned to the Trinity Engineering Center here in Livermore, California, to find out more about the making of and some of the future applications for this amazing technology. I'm back with John Eastwood, and I want to ask you, do you believe it possible that flywheels will actually end up in homes someday?
I most certainly do, yes, Holly. I believe that the future of flywheels in a domestic environment is extremely realistic, because I think that as we move forward, you're going to see it more and more difficult to have transmission lines across the country because of environmental reasons and aesthetic reasons. And that means there's going to be more of a concentration upon generation of power on a distributed basis, and also even in homes. And in order to have generation of power in a home, let's say from photovoltaics or even from a small windmill, you've got to have some means of storing energy in the home. Flywheel's a perfect device for that kind of application.
Is it any coincidence that your facility is so near the Lawrence Livermore lab?
No, Holly, it's not. It's not a coincidence. The actual originator of many of these ideas was a gentleman at Lawrence Livermore Lab. His name is Dr. Richard Post.
What impact do you see a flywheel will have on our future lives?
Holly, I see it in two areas. Firstly, in transportation, in hybrid vehicles. Take a bus, for example. I hope that we see hybrid buses where you have either a fuel cell or a compressed natural gas or other engine that runs at a constant load, minimal pollution. But in order to use that effectively, you've got to have some means of managing the power, because when you stop the bus, you want the energy to be stored. You don't want to waste it. Flywheel's great for that. Stop the bus, energy goes back into the flywheel, and then you accelerate with the energy that you've recouped from braking. Hybrid vehicles, in other words. Then if you turn to the home, I see that this technology could open up the whole possibility of putting renewables together with energy storage through the flywheel. And that means that, for example, the energy that's generated during the day by photovoltaics could be stored up in your home flywheel, and then you can use it at night, obviously to keep your home running as normal. So it's eliminating pollution, improving the efficiency of the system, and generally eliminating ugly and lacking aesthetic transmission lines.
Well, it's extraordinary. Well, there you have it, an inside look at the research and development and applications for the Trinity flywheel. Now, back to you in the studio.
Thank you, Holly. Well, that's been a look inside the makings of an invention that is already established in industry and now just beginning to make its mark on our global economy. I'm Doug Novak.
And I'm Christina Mare. Thank you for joining us along with Holly Paine here at the National Business Review. Until next time.